very much. All right, guys. So, what have we learned? We learned how to find profit maximizing quantity Q star in a graph capturing total cost as the snake and total revenue as the straight line, right? And we know it has to do with finding the greatest vertical distance between two lines, which can be obtained by running that tangent parallel to total revenue, touching total cost at the point of profit maximization, right? That's the technique. What is it good for? So now we can do it. So what? Well, here's what it's good for. Suppose price of pizza increases. Remember, total revenue is price times quantity. This is total revenue when price is $10, right? One pizza, $10, two pizzas, $20, three pizzas, $30. What would happen if price of pizza rose from $10 to $12? If you're running a pizza place and you suddenly can sell every pizza not for $10 but for $12, what would you do? Well, first of all, what happens to your total revenue?
Increase.
Increase. That means if you bake no pizza, now you will make more dollars, right? If you bake no pizza, what's going to be your total revenue?
Still zero.
Okay, so does it increase or does it not increase? Well, if you bake no pizza, it doesn't increase. If you bake no pizza, your revenue is still zero. But if you bake one pizza, your revenue will be $12, $24, $36, right? In other words, what really happens to your total revenue? It doesn't increase. It kind of
Just move up a little bit.
rotates, right? Let's graph it like this. Now you're going to have the blue total revenue. Does it make sense? It kind of rotates upwards. It still starts at the origin because you make no revenue if you bake no pizza, but it now rises steeper. That makes sense? It rises steeper. Okay. How is it going to affect your decision about baking pizza? Well, now you have a new revenue which is steeper. This is your new total revenue, the blue total revenue. It's steeper than the old revenue. Are you going to continue to produce Q star and generate, of course, larger profit? Can you do better than that?
Might be able to.
You might be able to. How could you improve your profit even more? Would you bake more than Q star or less than Q star?
Maybe a little bit more, less.
Why a little bit less?
I'm just looking at.
Remember, you're looking at tangent. You maximize the profit at Q star because this was a tangent parallel to your old black total revenue. Now you have blue total revenue, so tangent must also become steeper. But how do you make the tangent steeper? By sliding along total cost to the right or sliding to the left? To the right. You have to slide along the total cost to the right. Right? Something like this. In other words, you will now maximize profit at a quantity greater than Q star or smaller than Q star? Greater than Q star. And you will now generate a profit this large. That makes sense? Okay. The bottom line is, guys, let me clean up a little bit. bottom line is, at price $10, you maximize profit by producing Q star, right? When the price rises to $12, you will now produce new quantity, let's call it Q star star. In other words, you end up baking what? More pizza. Curious. What did we just find out? We found out that at price $10, you bake quantity Q star. At price $12, you bake quantity Q star star. Correct? That's what we found out. When you connect those points, what do you find out? You find a curve that shows quantity of pizza you're willing and able to produce at any given price. What do we call this curve? What do we call the quantity firms are willing and able to produce?
Exponential.
Oh, that's called supply. My goodness, what is this curve? It's a supply curve of that firm. Guys, we just found the supply curve of a firm. Because we showed that as price of pizza rises, firm is willing and able to do what? Bake more pizza. In other words, we showed that supply is upward sloping or downward sloping? Upward sloping. Are you glad we found out pizza? Are you glad we found out supply is upward sloping? Are you glad you live in the world where supply is upward sloping? Let me show you what difference it makes. Let me do it here. Imagine a market, not imagine, let's suppose this is a market with upward sloping supply, downward sloping demand. Here is a market with downward sloping demand and downward sloping supply. Here in this market we have what? Equilibrium. And we're studying efficiency of the equilibrium. Here in this market, what do we have? Nothing. There is nothing. Can you show me efficiency properties of equilibrium that does not exist? Not really. What if there are markets in American economy that look like this, that have downward sloping supply and therefore no well-defined equilibrium? If you have markets with no well-defined equilibrium, how much can you tell me about efficiency of those markets?
They aren't there.
They aren't there. It may not be efficient. There's nothing we can find out. In other words, is American economy really efficient? Well, if it consists of markets like that, there's really not much we can tell about efficiency of the American economy, right? But we just found out that supply, in fact, is upward sloping. And thanks to the fact that we have upward sloping supply, we have equilibrium and we have efficiency. Okay, so that's the first breakthrough we accomplished thanks to this tedious but ultimately useful analysis. We just showed that as the price rises, total revenue becomes steeper, firms are actually willing and able to produce more stuff. So supply is upward sloping. So that's a pretty big deal. That's a pretty big insight. By the way, why is it so? What about this convoluted picture really tells you that as the price rises, price of pizza rises, the pizza place is willing and able to produce more pizza? Why is that the result we're getting? It is a result we're getting because when price of pizza rises, total revenue gets steeper, correct? So we know firms maximize profit baking a quantity of pizza where total cost is steeper, right? So if this is total cost, this is where you're producing now. When price rises, you have to produce more because that's the direction in which total cost gets steeper, right? Can you tell me why total cost actually gets steeper as you produce more pizza along this segment? What makes it steeper? Exactly the same result why your total product curve has this shape here. Do you remember?
Diminishing marginal.
The law of diminishing marginal product. Because the law of diminishing marginal product makes total product grow at a slowing rate, it makes total cost rise at an increasing rate, and it makes firms produce more as the price goes up. It makes supply upward sloping. Let me tell you a dirty little secret. In microeconomics theory of cost, there's only one correct answer to every question. What is that answer? The law of diminishing marginal product. It drives all the major properties of cost functions. So sometimes I'll ask you, why is that shaped this way? Why is derived cost functions or functions shaped a certain way? I'll ask these curveball questions, and with a straight face you will always answer the law of diminishing marginal product, and you're always right. Because it drives all the major properties of cost functions, okay?
Law of diminishing
Marginal product.
marginal
Some economists refer to it as the law of diminishing returns. You may have heard that. Sometimes people use it in the media, but it's basically an archaic, older way to refer to it. The law of diminishing marginal product. Very good. So, what have we accomplished? We showed that the law of diminishing marginal product makes firms increase their output in order to maximize profit as the price of the good increases. In other words, the law of diminishing marginal product is responsible for the upward sloping shape of supply curve. Very good. Where do we go from here? We are going to spend the rest of today's class by finishing the most tedious and I would say the most boring part of this entire session. Once we are done with this hour, starting on Thursday, we are only going to reap the benefits, enjoy the fruits of our effort, and we're going to apply everything we learn to the rest of the analysis, and the results will just keep popping up, and you're going to be like, wow, you're going to be really dazzled just how awesome the results are going to be. But to get there, we have to go through this hour. Now, what is going to make this remaining hour even boringer? What really makes it even boringer is the fact that we're not going to learn anything new. We're going to spend an hour deriving something, and in the process we are not going to learn really anything new, in the sense we're not going to add any information. How can you do something for an hour and not add information? Let me show you how. Let's say you're a little kid and I tell you, Mom makes $60,000 a year. Okay? Wow, that's a lot of chewing gum. Okay? And then I tell you, okay, I'm going to show you something with this number. And as a result, you're really not going to know anything more about mom's salary. Like, what is going on, okay? I'm going to show you how to convert mom's annual salary into mom's monthly salary. With 60 grand a year, can you tell me how much you bring home a month?
3,000.
5,000, right? 5,000 a month.
That's it, no?
Well, there's 12 months. 12 times 5 is 60, right? So, how did you get this number out of that number? You take 60,000 divided by 12, right? If somebody never divided two numbers, it's going to take an hour to explain what you're doing, how you're doing it, right? And ultimately the result is 5,000 per month. My question is, if you know that someone makes 60 grand a year, and then I tell you that that same person is actually making 5,000 a month, did you find out something you didn't know before? Does this contain more information than that? Absolutely not. Both of these statements, both of these data points tell you exactly the same amount of information, only in different format, right? This is formatted to show you the wage per year, this one per month. This is exactly what we're going to do here. We're simply going to reformat this picture into a picture that looks different but contains exactly the same information. I'm going to show you how to do it, but the result is going to be a picture that contains exactly the same information as this one.
Okay, and then why are we doing this?
Excellent question. Excellent question. Why on earth are we doing it? Let me give you an answer right away so that you know why you're being subjected to this. Because the result is going to look like this. This is going to be there instead of total cost. Instead of total cost, you're going to have these two U's. Okay? So what? Instead of total revenue, you're going to have marginal revenue, average revenue, which is just equal to price of pizza. Let's say $10. So at $10, this is your average revenue, which is the same as marginal revenue. See, I didn't tell you what that is. I'm only telling you, answering your question, what it's going to look like. Why is this good? Because to maximize the profit, the firm will be producing profit maximizing quantity Q star, where marginal revenue equals marginal cost. I'll explain. That's what we have to do for an hour now. Can you show me quantity in this firm? Because there's a picture of a firm. Can you show me the quantity where marginal revenue equals marginal cost? If this is marginal revenue and this is marginal cost, where do they intersect? Right there. That makes sense? So that is Q star. So why are we not going to do it in this picture using these functions as opposed to that picture? Take a look at the two pictures and tell me why we're going to use this. Much simpler, much easier on eyes, and it turns out ultimately much more useful. There are ultimately things we can read off of this picture that would not be quite as easily seen in this picture. Okay? So this is, first of all, a matter of convenience, and then, of course, ease of squeezing the results out of it. So that's basically going to be the result. Then of course you can ask me, okay, how do I find a profit? Here the profit is the vertical difference between total revenue and total cost. Here, the profit will be found like this. This distance is a profit you make on every pizza, or on an average pizza. This is the profit you make on an average pizza. This area will represent the profit you make on the entire quantity. So that's the size of the profit. Okay? And that's the kind of a picture we're going to be using to analyze the behavior of a firm. Again, the idea it conveys is exactly the same as here, only it does so with a lot less clutter in the picture. Yes?
What does the AR stand for?
Average revenue, MR, marginal revenue, average total cost, marginal cost. Of course, the question is, what are these things? Well, that's what I'm going to tell you. That's what I'm going to explain to you. We're going to derive these cost functions and these revenue functions from total revenue and from total cost. In other words, we're going to convert, we're going to transform the picture with totals, total cost and total revenue, into a picture with averages and marginals. Okay? That's what we're going to do. And again, why? So that we can analyze the behavior of a firm in a picture like this rather than a picture like that. And I promise it's going to make it all worthwhile. Now, the nice thing is, I'm going to do this in a very intuitive and easy way. I'm going to do it graphically so that you see how that can be seen in graph. On the homework, I will ask you to actually find numerical values of marginal cost, average total cost, average revenue, marginal revenue. You will find it in terms of numbers. And then I'll ask you to graph it. Once you have those numbers, you graph them, what are you going to get? This is what you're going to get. Okay? So you're going to see exactly how it follows. But it really is just a reformatting of this picture into that picture. Now, once we have that, the rest is really an awesome discussion. The rest just is very intuitive and very, very pleasant to work with. So, let's take it step by step. How are we going to go about this? First of all, I said we're going to replace a graph with total cost, total revenue with a graph where there's average cost, average total cost, and average revenue, and eventually marginal cost and marginal revenue. So let's start with averages. In other words, derived functions, derived cost functions, derived revenue functions. By the way, why do we call them derived functions? Because we derive them from total revenue and from total cost. We derive them by some kind of derivation. So how do we do it? Let's start with average total cost. What do you think is average total cost? Let me put it this way. Suppose you're baking pizza. Baking 100 pizzas cost you the total cost of $700. Baking 100 pizzas cost you grand total of $700. What's your average total cost?
$7 a pizza?
$7 a pizza. How did you find the answer?
Just divide 700
By 100.
Just divide total cost by
By the individual cost.
By 100?
I mean, by
What's the...
number of pizzas.
number of pizzas.
Oh, there you go.
Sorry.
Congratulations. No, don't be sorry. I mean, no. But you get the intuition.
Okay.
In other words, it is your total cost per pizza, just like you said. Per pizza means divided by number of pizzas, right?
Mm.
So average total cost is total cost divided by quantity of
Quantity.
pizzas. That's it. What is the average revenue? What do you think is the average revenue?
Total revenue.
Say it very loud.
Total revenue divided by quantity.
Total revenue divided by quantity. Congratulations. You just derived the first set of derived functions. You derived your averages, right? Average total cost, average revenue. Now, let's learn a little bit more about average revenue. You said average revenue is total revenue divided by quantity. But what do we know about total revenue? What is total revenue?
Price times quantity.
Price times quantity. So if average revenue is total revenue divided by quantity, it is price times quantity divided by quantity, which is just price. That means average revenue is actually price of pizza. Why? Does it make any sense to anybody? Okay, let's say you're running a little pizza place. You're selling every large one-topping pizza for $10. How much revenue do you generate on each pizza you sell? C'est là? Correct. Why? Because that's the price at which you sell it. Okay, that's exactly what it tells you. On average, you get $10 per pizza. Why? Because that's how much you sell every pizza for. That makes sense? That's exactly what this tells you. Okay, guys, so far so good. Looked a little bit scary, but you see it's extremely intuitive. So your average revenue is just equal to price. Average total cost is total cost divided by quantity. Let's now see what a graph would look like. Let me erase, I guess, this. First of all, what a graph of average revenue would look like. If average revenue is just the price, $10 you sell pizza for, then the graph is going to look like this, right? Just the price, $10. That's your average revenue. That's what that says. That makes sense? Okay, so far so good. We know what average revenue looks like. What is the average total cost going to look like? Well, that's a little bit trickier. That's a little bit trickier. We know that total cost is a snake, right? It looks like this. Right? That's total cost. We know that average total cost is total cost divided by quantity. Total cost divided by quantity. Let's say you're producing this quantity. Okay? What is your total cost? This is your total cost, correct? So this is your total cost. And this is the quantity you're producing. What is average total cost? It's a per pizza total cost. You find it by dividing total cost divided by quantity. So you are dividing total cost by quantity. Right? Average total cost is total cost divided by quantity. What could that be? Have you taken any math class where you took this and divided it by that? Where did you do that?
Wait, say that again?
Have you ever taken math class where you would take this distance and divided that by this distance? Let me give you a hint. You call this a rise, and you call this a
Run.
run. In other words, when you calculated rise over run,
Statistics.
I don't know if negative, but definitely a
Those
slope. Remember? Slope. Rise over run.
MX plus B.
There. Oh my gosh. In other words, average total cost, which is defined as per pizza total cost, can geometrically be represented as rise over run, right? Because total cost is rise and run is quantity. And we know when you divide rise over run, you get a slope, correct? Wonderful. So we know slope is a geometric representation of average total cost. Slope of what? Slope of what actually represents average total cost? Slope of total cost, right? Slope of that snake tells you average total cost, right? Is that what you're saying? That slope of total cost tells you average total cost because it's rise over run, correct?
Yeah. For me.
Okay. You know what? I'd love to teach this in like middle school before kids actually have to take math. Because then you will take math a lot easier because you would see what it's good for. It's so hard to learn math before you know what that thing is good for. Look, when you saw rise over run, you had a graph and you had a line, right? And they told you, look, that line has a slope, right? How do you calculate the slope of that line? You take rise and you divided it by run, right? Rise over run. Correct? And once you do it, once you divide rise over run, you find the slope of what? Slope of that line. Correct? Wonderful. Here, I take a rise over run, and I find slope of what? You said slope of total cost, then I say no. When you divide rise over run, you find a slope of a straight line starting at the origin. Is that correct? Well, that's what you learned in your math class. Rise over run is the slope of a straight line rising from the origin, correct? Can you see a straight line rising from the origin? Why can't you see a straight line rising from the origin? Because it ain't there. You're absolutely right. In other words, when you divide rise over run in this graph, you find a slope of something that's not there. In other words, average total cost has a geometrical representation of a slope of something that's not in the graph. So let's put it in the graph. What would it be? That slope of something that can be calculated as rise over run. Well, it would have to be a straight line rising from the origin, right? So it would be a straight line like this. Right? Maybe I should make it blue. This would be a straight line rising from the origin, and this would be its rise, and this would be its run. And once you divide rise over run, you get slope of that blue dashed line. That makes sense? Okay. So the truth is that if you're producing quantity Q, and you divide total cost by the quantity, you find average total cost, which is the slope of a line starting from the origin running through that total cost at that quantity. What do we call that funky blue dashed line? We call it a ray. Ray. It's just a geometrical object. A ray emanating from the origin. In other words, what I'm suggesting, guys, is that average total cost can be represented as a slope of a ray crossing total cost at that quantity. What is this insight good for? You take total cost, okay? Now, spend that with several rays. Take a look at them and tell me what happens to those rays as we bake more and more and more pizza. Let's start with this ray. Is that ray steep or flat? It's quite steep. As you bake more pizza, that ray becomes less steep, becomes flatter. And as I bake even more pizza, that ray becomes even less steep, even more flatter, right? And then it becomes even more flatter. And then, as I bake even more pizza, the ray is becoming what? Steeper again. In other words, first, as I bake more and more pizza, the ray is becoming flatter. And then the ray is becoming steeper again. That make sense? All right. So, as the ray becomes flatter, what happens to its slope? Is the slope getting bigger or smaller? As I bake more pizza, slope of that ray is becoming smaller. And then when I reach this quantity and I bake more pizza, then the slope is becoming bigger again, right? It's getting steeper. Very good. Congratulations, we just derived average total cost. That's what average total cost looks like. And once again, on the homework, I'll give you actual numbers. You plug them in this formula and you will have numbers for it. And then I ask you to graph it. Wait, guess what you're going to get? A U-shaped average total cost. Okay? So, we have derived average total cost. We have derived average revenue, which is just a straight line, and average total cost, which is a U-shaped function. So averages are done, guys. We know what average total cost looks like. It's a U-shaped function. We know what average revenue looks like. It's just a horizontal line. Let's now go to the second set of derived functions, and those are marginals. Now these are even less intuitive, well, less intuitive. Averages are intuitive. It's per pizza revenue, it's per pizza cost, right? What are marginals, guys? Who on earth uses the word marginal? What was the last time you thought of someone, well, this was really marginal of you? So, is that a word you use on a day? See? Who uses words like marginal? Economists, because their lingo comes from about 100 plus years ago, when British economists still used words like marginal. Okay? So we kind of, literally. Yeah, just like that. So, what do we mean by marginal, really? I mean, if you use the word marginal, what would you use it for?
Small.
Small. It helps me marginally, right? Not that much. Barely, just so-so. Yeah, basically, in a similar way, we're using the word marginal in this context. But again, look, we're talking about marginal cost. What could be marginal cost? It's not like it's a small cost, or it's a cost that barely even figures in. No, it's actually a cost of increasing your production marginally. Okay? Suppose you increase your production just marginally. What happens to your cost? Well, it goes up, right? That's what we mean by marginal cost. Now, how are you going to use it on the homework? How do we use it actually in the spoken English today? It's the following idea. Suppose you're baking 50 pizzas, and you're incurring certain cost of baking 50 pizzas, right? What's going to happen to your cost, to your total cost, if you start baking 51st pizza? In other words, you increase production of pizza by 1. Can you increase production of pizza by 1 without any additional cost? No, definitely there's going to be additional cost of that dough, of that tomato paste, and possibly a worker has to stay a few more minutes longer or something, right? So there's cost associated with increasing production by 1, correct? Well, what is the cost of increasing production by 1 unit? It is the marginal cost, guys. Okay? So marginal cost is the cost of producing an extra unit of output, additional unit of output. Okay, that's marginal cost. Okay, what do you think is the marginal revenue? It's the additional revenue you generate if you increase your production just marginally, let's say by 1 pizza, okay? If you bake 1 more pizza, what's going to happen to your revenue? If you bake and sell 1 more pizza, what's going to happen to your revenue? It's going to go up by how much?
How much your pizza costs?
Okay, not cost, how much it sells for,
Oh, so
which is
that's
right, which is the price.
Yeah.
And what is the price of pizza? Well, if it's $10, then what's the marginal revenue of baking and selling another pizza?
I know.
Congratulations, you just found your marginal revenue, right? It's $10. In other words, when you're selling pizza, every pizza for $10, how much do you on average get for every pizza? $10. How much are you gonna get if you sell another pizza? $10. If you bake and sell another pizza, you're gonna get $10 for it, right? On average, you get $10 for every pizza. Why? Because you sell every pizza for $10. That's why average revenue, marginal revenue, is just equal to price. But how about marginal cost? What is marginal cost? Well, marginal cost is the cost of baking additional pizza, right? Baking additional pizza. But how do we find it, guys? We know average total cost is this U-shaped function which was derived as the sequence of slopes of rays emanating from the origin, hugging the total cost curve for various quantities, blah, 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 right? What could be marginal cost? Well, much of math, especially in micro, is very mathematical. And if you ever go to grad school, you will learn all about these derived functions. And every single time you are about to derive any marginal function, you will use one mathematical operation. And that's going to be derivative. Okay? Marginals are always found as derivatives. You don't have to remember this, I will never ask you. This is principles class. You're not going to be taking any derivatives. But technically speaking, marginals can be derived as derivatives of functions. So you could say mathematically, marginal cost is a derivative of total cost with respect to quantity. Okay, so mathematicians call it a derivative. What do English-speaking folk call derivatives? Is there an English word for mathematikese word derivative, or economese word marginal? Economists call it marginals. Mathematicians call it derivatives. What do normal people call it? Guys, dirty little secret no mathematician will tell you. Well, some will. Slope. English for derivative is slope. English for marginal is slope. What is marginal cost? Slope of the total cost. It's a slope of the total cost. So, if you want to derive marginal cost, you have to take the total cost and find its slope. Here is the total cost. Is it a straight line or is it a curve? Is it a straight line or is it a curve?
Curve.
It's a curve. It doesn't have a straight bone in it, right? It's a curve, and it curves in all kinds of ways. Does it have the same slope everywhere? If it had the same slope everywhere, it would be straight. but it's not straight, so it has slope all over the place. What's the slope of total cost at small quantities? Is it steep or is it flat? It's quite steep. And as I bake more and more pizza, total cost is becoming flatter. And then I bake even more pizza, total cost is becoming steeper again. So it starts steep, then it gets flatter, and then it starts being steeper again, right? So what happens to the slope of total cost as I start baking more and more pizza? Slope is getting smaller, and then as I bake even more and more pizza, slope is getting larger again. Congratulations, you just derived marginal cost. Again, U-shaped function. Why? Because cost gets flatter, and then steeper again. So marginal cost is a U-shaped function. Oh my goodness. Let's summarize. What have we just learned? We learned that derived revenue functions are very simple. Both marginal revenue and average revenue are just equal to price. Very simple. On the other hand, derived cost functions, both average total cost and marginal cost, are strange. They're both U-shaped. Because it has something to do with strange curviness of total cost curve. Then, of course, a question arises. If average total cost and marginal cost are both U-shaped functions, how do they relate to each other? Let me erase this top and let me bounce some ideas against you guys. You have two U-shaped functions. You put them in one graph. Maybe they are one and the same. Maybe they sit on top of each other. Maybe they stand next to each other. Maybe they intersect each other in some way. Can you tell me what is the mutual position of average total cost and marginal cost? Who knows? No way to tell. Any of these is possible, right? Or any other combination you can come up with. So how are we going to find out? Okay guys, we're going to find out by sheer intuition. Yes, we still have a few minutes. But now it's actually going to get fun, guys. We're going to find out by sheer intuition, talking about something that has absolutely nothing to do with cost, or pizza, or econ. Let's talk for a moment about your grades. Yeah, I promised fun. Anyways, here's the deal. These are exams you're taking. First exam, second exam, third exam, fourth exam, fifth exam of the semester, okay? On each exam, you're going to earn a certain grade. First exam is going to earn you some grade, second exam is going to earn you a certain grade, and so on. Depending on what grade you earn, of course, you will either improve your GPA, or you will damage your GPA, or you will keep your GPA, right? Let's assume you're entering the final exam week with a perfect 4.0. You are a brilliant student, okay? So this is 2, this is 3, and this is 1, right? So you're entering the final exam season, or final exam week, with 4.0 GPA. You've been at college for a while, you've been doing this thing, so you think to yourself, oh gee, I have this thing figured out, I know how to study in college, 4.0, it's so easy. However, things happen. You fall in love. You suddenly have all these awesome other things to do and think about that have absolutely nothing to do with exams and learning. So you enjoy the semester more than any other semester before The only problem is, final exam week comes, you're going to take your first exam, and you haven't studied anything. And so you go, you're hoping you will luck out, but it's not that good. It was an easy exam, so you didn't bomb, but you only earned a B. What's the value of the B? 3, right? So this is the grade you earned on the first exam. What's the impact of that B on your spotless 4.0 GPA? You will damage your GPA, right? Does it mean your GPA suddenly sinks to a D or something like that? No, it's definitely not going to be 4.0, but it's still going to be above 3.0, right? You're just going to pull it down some. So let's say this is your GPA, okay? It's lower than it was before. Then you're going to take the second exam. You haven't studied anything for it. It's a harder subject. You go, you're hoping for the best, but your best now is a C. My goodness, what just happened to your slightly dented GPA now that you earned a C? You damaged it even more. So your GPA goes further down, right? We don't know exactly how down, we don't have all the information, but you get the idea. Definitely pull it down, right? You go take the third exam, and that's the one you've been afraid of the most. It's hard, I don't know, micro principles or something. Some kind of math, statistics. And you barely scrape by. You earn a D. What's going to happen to your GPA? Oh, it's going to definitely damage your GPA, right? Very good. Let's say your GPA is now only 3.0. In other words, you started the semester with 4.0 GPA, and your first 3 grades came in bad. In what sense bad? There are students who actually celebrate when they get a D, right? Go throw a party. For you, it's not good. What makes these bad grades for you, for the kind of student you are? The fact is that you're 4.0. It means every single one of these grades, B, C, and D, for you are below average grades, right? And since you're getting below average grades, your average suffers, right? So let's say after you get these 3 below average grades, you damage your GPA so badly that it's no longer 4.0. Let's say now it is 3.0. Okay? So by getting 3 deeply below average grades, you damaged your GPA and pulled it down from 4.0 to 3.0. Okay? Your parents call you, ask you how you're doing. You finally fess up, and they tell you, okay, you're going to do much better from now on, or else we're cutting off your aid or whatever, okay? So you're going to take the 4th exam, and you realize, my goodness, a lot is hinging on my performance from now on. So you start studying. And you study really, really, really hard. Of course, at this stage, it's not, you don't have enough time to turn everything around immediately. So on that 4th exam, you actually earn a B. You earned a B. You are going to that exam with a 3.0 GPA. What is your GPA after you got a B? It's still a B. Does that make sense? My question is, what kind of grades do you have to start getting to improve your GPA? You have to start getting above average grades. That make sense? So you go to the 5th exam, and in order to turn your GPA around, you have to get an A. So you do everything you can to earn an A. Of course, now that you earned an A, does it mean your GPA jumps up to 4.0 again? No, it just slightly
3.5.
improves. That makes sense? Okay, guys. Let me connect these lines. Let's start with the grade. You start with a B, then you got a C, then you got a D. Then you had that fateful call with your parents. You earned a B and an A. Okay? Those are the grades you earned. Because you were earning bad, below average grades, your GPA was going down. When did that fall in your GPA stop?
3.
When you start getting average or above average grades. That makes sense? Okay, what did we learn from this exercise? As long as you're getting below average grades, your average will go down. As soon as you start earning above average grades, your average will go. Are you shocked? Okay. Guys, what we just found out applies not just to your grades. It applies to all averages and all marginals. This is just the marginal grade, the grade you get on the next exam. This is just an average, your GPA. The same principles apply to costs. In other words, if this is your marginal cost U, then as long as you're baking each additional pizza at below average cost, your average cost will go down. As soon as you start baking each additional pizza at above average cost, your average cost will go up. Congratulations. Done. That's all there is to it. So your derived cost functions, average total cost and marginal cost, are two U's that intersect in a very particular way. Marginal cost intersects average total cost at the minimum average total cost. Right? Why? Because as long as marginal cost is below average, average goes down. As soon as marginal cost is above average, average goes up. That's it, guys. That's all there is to it. Are you impressed? It kind of starts making sense, but you still don't see why we did this. So now we know what average and marginal cost looks like. At the same time, we found out that average and marginal revenue are just a straight line, right? Equal to price. Average and marginal revenue are just a straight line equal to price. So that's it. Now, instead of having total revenue and total cost, we have average and marginal revenue and average and marginal cost. All right. So what's next? Next is asking, what quantity is this firm going to produce? Just like we asked it here. And we found Q star because tangents and slopes and all that good stuff. Here, again, let's use intuition. Let's say you're selling every pizza at $10 because that's the going price of pizza, okay? Let's say you're baking 50 pizzas now. 51st pizza, if you decide to bake it, it's going to increase your cost by $7. In other words, the cost of baking 51st pizza is $7. Should you bake it? Think about it. Why?
Because you can sell it for 10,
Because you will sell it for 10 and you will get
a profit of $3.
additional $3 in profit. So should you bake the 51st pizza?
Yes.
Absolutely. 52nd pizza is going to cost you $8 to bake it. Should you bake it?
Yeah.
Yes.
You're right.
Guys, greed is good. Okay? You want to maximize profit. That's what you got into business for. If 52nd pizza costs you $8 to bake, you can sell it for $10. Of course, you can make $2 extra profit. So should you increase production to 52 pizzas? Yes. 53rd pizza, $9 to bake. Should you increase production to 53 pizzas?
Not that much.
Why not?
A
You can-
dollar.
It costs you $9 to bake. You will sell it for
$10.
10.
11.
You still,
You have no control over price. You can still make an extra $1, right? Okay. Why not? You're going to produce the 53rd pizza. 54th pizza. Let's say it costs $10 to produce. Should you bake it?
no.
Why bother? Is it going to increase your profit?
No.
Is it going to decrease your profit? No. 55th pizza, $11 marginal cost. Should you bake it? Definitely not. Because you would only sell it for 10, you would actually
Lose $1.
lose $1. So it would reduce your profit. Let's suppose for some reason you are baking 54 pizzas. 54 pizzas. The last pizza was baked at the marginal cost of $10. Do you want to increase production from 54 to 55? Do you want to decrease the production from 54 to 53? Is it going to increase your profit? No. Do you have any reason to increase or decrease production? No. Why? Because you're maximizing your profit. What is true at that 54th pizza? That it costs you $10 to produce and you sell it for $10, correct? In other words,
I mean, I wouldn't do that.
marginal cost of baking that pizza is equal to $10 that you're selling it for. That makes sense? That's the condition. So, how much pizza should you bake if you want to maximize profit? Keep increasing quantity of pizza, keep increasing quantity of pizza until your marginal cost reaches the price at which you're selling it, and then don't produce anymore. That makes sense? Now, what would you do if 53rd pizza costs you $9 to bake, but 54th pizza costs you $11 to bake? How much would you produce? 53 pizzas, because you make extra dollar on that 53rd pizza, you would lose $1 on 54th pizza, so you wouldn't. In other words, keep increasing as long as you get as close as possible to this condition, right? As long as marginal cost is catching up with price. Once you reach production at which marginal cost is equal to price, or God forbid exceeds the price, don't increase production anymore. That make sense? What you're looking at is the profit maximization condition. Very simple, very intuitive profit maximization condition. So, increase production to the point where price equals marginal cost.
Profit max, what was it?
Profit maximization condition. Profit maximization condition. So, if this is the price at which you are selling pizza, what quantity of pizza should you produce in order to maximize the profit? Quantity at which price equals marginal cost. Where does price equal marginal cost? Right there. Ta-da-da. Simple, easy, straightforward. Okay? No longer do we have to draw tangents and look at slopes. You just look at P equals MC and it gives you the quantity at which firm maximizes the profit. That makes sense? All right. Now, I know you're tired. I know you had enough. The good thing is, I will never test you on deriving this the way we did it in class. I just showed you. This is how it's derived. On the homework, you will just have to find numerical answers. You will have to find average total cost, average revenue, which is going to be very easy. Just plug the numbers in and numbers pop up. The beauty of this is, when we meet again on Thursday, we will simply use this structure of the firm and study its behavior. And we're going to derive some awesome results. We're going to see how the firm is doing in the short run, how the firm is doing in the long run. And towards the end of Thursday class, guess what we're going to find out? The secret of efficiency. The holy grail of microeconomics. Thank you very much for your attention. See you on Thursday.